It's not a course wherein you have a problem, you have a set of equation, solve it using that equation. So that's not how things work in solid mechanics. So it's basically trying to understand the concept and then from there identify an equation that can be able to represent that problem. So as you can see, we have different failure criteria, and different failure criteria will have different types of analyses. We had the principal stress failure criteria. So we've had that wherein we had to determine the principal stresses, sigma 1, sigma 2, and sigma 3. How do you know which one is sigma 1, sigma 2, and sigma 3? Sigma 1 is the maximum stress. That's the tensile stress that's going to try to stretch your material. Sigma 3 will be the minimum stress that's going to compress. Normally it's a negative value. So it's going to compress your material. And sigma 2 is in between. So these are the things that you have to remember when you have a state of stress, a full matrix sigma. And then once you have sigma 1, sigma 2, and sigma 3, sigma 1 will be the maximum, sigma 3 minimum, and sigma 2 in between. Okay? So that's the thing about the principal stress. So we also have another failure criteria. The other failure criteria is the distortional or distortion failure criteria. And what is that? That uses your von Mises. So your von Mises stress equated with the yield, then you have now your failure criteria. Of course, you have to consider that you have to have a factor of safety in your design. But of course, if you're trying to analyze the maximum capability of your material, then you don't really need to put in a safety factor. So what am I saying? So from your state of stress, so from here you will be able to get your